It may seem unlikely that space debris could be able to harm someone here on Earth. However, like most things, it is a possibility, and we can never say never. So is it essential to take the threat of new satellites, rockets, and space missions more seriously? It is, of course, preferable to avoid deaths rather than cause them. Stay tuned as we discuss what scientists have said about the risk of someone actually being killed by space junk. First, let's go through what we know about space trash. Recent research published in the Nature of Astronomy predicts rocket part fatalities during the next decade. Every minute, invisible space debris crashes down around us. Asteroids and comets drop 40,000 metric tons of dust on Earth's surface each year. As reported by the James Webb Space Telescope, such debris may cause harm to spacecraft. A bigger piece sometimes comes as a meteorite, and a tens of meter wide body excavates a crater once every 100 years. Fortunately, as indicated by the lack of dinosaurs today, kilometer-sized objects seldom reach the Earth's surface. This is natural space debris, and its arrival is unexpected worldwide. The new research looked at uncontrolled space debris, including leftover rocket stages from rocket launches and satellites. The scientists used mathematical modeling of rocket components, inclinations, and population density underneath them, as well as 30 years of satellite data to determine where rocket debris and other space trash settle on Earth. Within the next decade, there is a modest but considerable chance of components re-entering the ecosystem. The South is more prone to experience this than the North. Rocket corpses are 3 times more likely to land in Jakarta, Dhaka, or Lagos than in New York, Beijing, or Moscow. Moving on to other conjectures about the author of Nature Astronomy, the scientists also calculated a casualty expectation, which refers to the possible threat that uncontrolled rocket re-entries pose to human life over the following 10 years. Assuming that each re-entry scatters potentially fatal debris across the 10 square meter region, they discovered that the average likelihood of 1 or more casualties over the following 10 years varies from 10% to 100%. The chance that debris from satellites and rockets may threaten humans on Earth's surface or impede aviation traffic in the atmosphere is still considered exceedingly unlikely. The bulk of the study on this sort of space debris has focused on the hazard that dead spacecraft represent in orbit, which might possibly interfere with the smooth operation of active satellites. Another type of waste is orbital explosions, which are generated by wasted fuel and batteries. The amount of mishaps both in space and on Earth, such as the one that occurred during the launch of the Chinese Long March 5B, is quite likely to increase as the number of individuals joining the rocket launch industry grows and shifts from government to private company. According to the latest research, the 10% number is a conservative estimate. So what can we do? Using pricey technology, it is feasible to control debris re-entry. After a spaceship's lifespan, unused energy, like fuel or batteries, might be passivated rather than stored. It is possible to minimize satellite orbital debris. Decommissioned satellites may be engineered to burn up in low Earth orbit. SpaceX and Blue Origin are working on reusable rockets. These return to Earth in a regulated way, leaving less paint and metal particles behind. Many organizations evaluate risks. The European Space Agency plans to gather space trash using a 4-armed robot. The UN Office of Outer Space Affairs produced space debris mitigation guidelines in 2010 and 2018. The authors of the new report stress that these are guidelines, not international regulation, and that they do not define how to conduct or manage mitigation actions. Advances in technology and mission design would reduce uncontrolled re-entry of spacecraft debris, lessening the worldwide hazard risk. Uncontrolled rocket re-entries are a problem that must be addressed collaboratively, and each launching state must find solutions. The prohibition on ozone-depleting chlorofluorocarbons required international cooperation. Unfortunately, this sort of behavior is frequently accompanied with a massive Northern Hemisphere event. Protocols and standards develop throughout time. For the first time in 70 years, the first satellite will be launched in 5 years. It would be a suitable way to commemorate the anniversary if all UN member nations signed a reinforced, legally enforceable international space debris treaty. An agreement would benefit all countries. What was discovered in the ocean is up next. Explorers have discovered a series of inexplicable, perfectly matched holes punched into the seabed, roughly 1.6 miles, 2.6 kilometers, below the ocean's surface, with no idea who or what created them. The holes were discovered by the NOAA Okeanos Explorer team while studying the Mid-Atlantic Ridge, which is part of the world's largest mountain range. The holes are in a straight line and occur at regular intervals, surrounded by little slit mounds. This isn't the first time holes have been found in the area. On a dive in 2004, 2 marine scientists from the United States National Marine Fisheries Service noticed strange hollows in the ocean floor. These holes had previously been been noticed from the region. NOAA researchers said on Facebook, the slit mounds around the holes give the impression that they were excavated by something. Scientists stated in 2004 that the holes were formed by a creature living in or sifting through the sediment on the bottom, but no one has seen such critters generate them. Therefore, their specific origins remain unknown. According to NOAA's Facebook post, theories range from leaking gas to underwater human boats seeking riches to ants, aliens, and starfish cartwheeling. The unanswered mystery is comparable to an underwater golden brick road to Atlantis, discovered by ocean researchers in May on top of an undersea mountain in Hawaii. Scientists think the pathway was formed by several volcanic eruptions that heated and cooled the seafloor. However, finding the source of the holes may take some time. The researchers will continue to explore the area as part of the Voyage to the Ridge 2022 expedition, which plans to map the region's coral reefs and sponge ecosystems, as well as evaluate the region's hydrothermal vents, fracture zones, and rift zones. If they're lucky, they may be able to catch the hole maker in the act. Following that, NASA issues a statement regarding Chinese space debris. The People's Republic of China, PRC, did not share specific trajectory information as their Long March 5B rocket fell back to Earth, said Bill Nelson, NASA administrator, on Saturday, July 30th. All spacefaring nations should follow established best practices and do their part to share this type of information in advance to allow reliable predictions of potential debris impact risk. This is critical to the responsible use of space and to ensure the safety of people here on Earth. Next, a 4.5 billion-year-old Martian meteorite reveals Earth's origins. What are the similarities between Mars and Iceland? Not so much these days. However, it's plausible that the red planet had a crust similar to Iceland today, more than 4.5 billion years ago. This finding, concealed among the oldest Martian debris discovered on our planet, has the potential to offer knowledge about Earth that has been lost due to billions of years of geological movement. It might also help explain why the Earth evolved into a planet capable of supporting a diverse range of life, whereas Mars did not. These discoveries about Earth's history come from a recent paper that explains how scientists discovered the possible Martian origin of the 4.48 billion-year-old meteorite known as Black Beauty. Its genesis is one of Mars' oldest areas. An international team of researchers, including a Northern Arizona University scientist, published their findings in the journal Nature Communications on July 12th. This meteorite documented the earliest stage of Mars history, and by extension, the evolution of all terrestrial planets, including Earth, said Valerie Perret, a postdoctoral researcher in the Department of Astronomy and Planetary Science. Because the Earth's old surface was lost, mostly owing to plate tectonics, witnessing similar settings in very ancient terrains on Mars provides a unique insight into the ancient Earth surface that we lost a long time ago. Finally, let's take a look at a Mars meteorite that is similar to Earth's origin. The scientific team, led by Anthony Legain of Australia's Curtin University, sought the origin of a Martian meteorite, formerly called NWA Northwest Africa 7034, because it was discovered on Earth. This meteorite, whose composition suggests that Mars experienced volcanic activity similar to that observed on Earth, documented the early stages of Mars history. Although it was expelled from the surface of Mars 5 to 10 million years ago as a result of an asteroid collision, its source location and geological context are unknown. This study team investigated the chemical and physical features of Black Beauty to determine its origin. They discovered it came from Terra Cimmeria Cyrenum, one of Mars' most ancient areas. It might have a surface comparable to that of Earth's continents. Mars, for example, has impact craters all across its surface, making it difficult to pick the proper one. Legain's team previously created a crater recognition system that analyzes high-resolution photos of Mars' surface to locate tiny impact craters, discovering around 90 million, as small as 50 meters in diameter. They were able to locate the most likely ejection location in this study, the Karatha crater, which scooped ejecta from an earlier crater called Kujert. Can the Earth and Mars have the same ancestor? What are your thoughts? And that concludes our video for today. I hope you enjoyed it. Make sure you press the subscribe button on your way out. And thank you for your time.